Gauss's law. Gauss's law is a very important law in electrostatics. This law states that the total electric flux around a closed surface is 1 by epsilon 0 times the net charge enclosed by the surface. Let us consider a charge q and surrounding this a closed surface of any shape. So we know that electric flux will come out of the surface from the charge. So the law states that the total flux we can give the symbol phi. The total flux will be equal to 1 by epsilon 0 times the net charge enclosed by the surface. So phi is equal to 1 by epsilon 0 times the net charge. Q is the net charge enclosed by the closed surface. Now we can express the flux. We have learned that d phi, the small flux, coming out of a small area dA. If we have a small area dA, this is a small area dA. The total flux coming through the small area dA is equal to, we have learned this equation, d phi is equal to E dot ds, E dot dA. dA is a small area, E is electric field. Now we can expand this, the total flux, if this is a small flux, the total flux is equal, we have to integrate this. Total flux is equal to integrating closed surface integral, E dot dA. E dot dA. Now we can take the dot product. When you take the dot product, phi is equal to surface integral, closed surface integral. E dot dA means E into dA into cos theta. Here what is the angle theta? Theta is the angle between the electric field vector and the area vector. So we can combine these two. We can write closed surface integral E dA cos theta. That is equal to E dot dA is equal to 1 by epsilon 0 times the net charge enclosed by the surface. This law is known as Gauss's law. So Gauss law says that the net charge enclosed by a closed surface into 1 by epsilon 0 will give the total flux coming out of the surface. This is called a Gauss's law. Now we'll have a proof for this law. To prove this, we'll consider a charge q and we'll consider a closed surface also. The closed surface will take in the shape of a sphere. So let us have a charge q here. I have a charge q here. This is a charge q. Then I am going to consider a point P here. This is a point P at a distance r from the charge. Now at this point, the charge q will produce intensity. This is the direction of the intensity vector. What's the value of this intensity? Intensity is equal to 1 by 4 pi epsilon 0, the charge by distance square. This is the equation for intensity. Now we are going to consider a closed surface. For simplicity, let us take a closed a sphere. We can take a sphere of radius r. So I am going to consider a small area of the surface surrounding the point P. I am now considering a small area. The small area has a value. We can take the value for small area dA, and I need area vector. Area vector is always perpendicular to the area. So if this is small area, this will be the area vector dA. This is the electric field vector. Both are in same direction here. Now what I am going to find is, I need to find the total flux coming through the small area. So for small area, we have a small flux d phi is equal to E dot dA, dot product of these two vectors. We can expand this E into dA into cos theta. But E and dA are in same direction. So theta will be 0. Theta will be 0 degree. Therefore, you will get E into dA into cos 0. Cos 0 has a value 1. So small flux through the small area is equal to E into dA. This is the small flux. Now we need to find the total flux through the entire surface. To find the total flux, what we will do, we will integrate this. So integral d phi is equal to closed surface integral d phi is equal to closed surface integral E into dA. So our total flux is equal to phi. Left side is phi, integrate in this, right side. E is constant. At every point on the surface, E is constant because each point on the surface at equidistant from the charge. So phi is equal to E integral dA, closed surface integral dA. What is integral dA? Integral dA is equal to total surface area. So I can write flux of I is equal to E into A. E is the electric field and A is the total surface area of the surface. This closed surface has given a name called Gaussian surface. So this is a Gaussian surface. A is the area of the Gaussian surface. Now what is the area of the Gaussian surface? For sphere we know that 4 pi r square is the area. So phi is equal to E. E has a value 1 by 4 pi epsilon 0 q by r square. And what's the area? Area is 4 pi r square. Now I am going to cancel terms like 4 pi cancel here. R square is also cancelled. So what is the total flux? It is equal to q by epsilon 0. So the total flux coming out of the closed surface is equal to q by epsilon 0 or 1 by epsilon 0 times the net charge enclosed by the Gaussian surface. This law is known as Gauss's law. It's a very important law in electrostatics. Okay, thank you.